Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. We are doing the chapter on areas related to circles, right? In this exercise, we will calculate the areas of combinations of figures, right? We are comfortable with calculating the areas of segments, sectors and various other geometrical figures. Now we will combine those figures and will calculate the areas of combinations of figures. So let's start with this example here and then we will get the idea what I am talking about. So now in this question, we have got two circular flower beds on two sides of square lawn ABCD, right? And the side of this square lawn is 56 meter. If the center of each circular bed is on the point of intersection O, right? This O will act as the center, right, for this circle. This arc is part of the circle which has got center O, okay? Find the sum of areas of the lawn and flower beds, right? So we are supposed to calculate this entire area, this square plus two segments, right? This is one of the segments. So if you calculate the area of one segment, you can just double it to calculate the areas of these flower beds, right? Another option that we can do is we can calculate the areas of these two sectors, this sector and then this sector, okay, and add the areas of these two triangles in it, right. So let's start by calculating the area of sector AOB. Area of sector AOB. What is this angle? This is a square, so this angle is 90 degrees. So what will be the area of sector AOB? It will be 90 by 360 pi r square. What is r? R is this OB, right? How do you calculate OB? We can calculate OB by using Pythagoras theorem in triangle, let us say BOC. If I use the Pythagoras theorem, if this is r, this is also r, right? So I can say that r square plus r square is equal to 56 squared, right? So 2r square is equal to 56 square, and what is this? R square will become 56 into 56 divided by 2, right? So what is r? R is 56 by root 2, right? In other words, you can say this is 28 root 2 and the unit is meter, okay. So now if you want to calculate this area, the area of this triangle, what we can do is half into r, half into base into perpendicular, right. So now we have got this r, so we can calculate area of sector AOB, which is area of sector AOB is equal to 90 by 360 pi r square. So 28 root 2 into 28 root 2, okay. So this is equal to 1 by 4, pi can be taken as 22 by 7. So 28 root 2 into 28 root 2, right. So this root 2 into root 2 will become 2. So this will give me 2 here and this will be cancelled 11 and 7 into 4 is 28. So in the numerator I have got 11 into 4 into 28, right. And what is 28 into 4? 112. 112 has to be multiplied by 11. So you will get 112, 2, 3, 2, 1. 1232 meter square is the area of one sector. And how many such sectors do we have? We have got two sectors, AOB and then DOC. So area of sector AOB plus area of sector DOC is equal to twice of 1232. which is equal to 2464 meter square, right? So we have got areas of these two sectors. When I say sector AOB, I mean this sector here, right? So now I have got the area of these two sectors. I just need areas of these two triangles. I'll add this area and then I can get the area of this combination of figure. And we know that area of this triangle BOC, area of triangle BOC is nothing but half into base into perpendicular, and base and perpendicular are equal and is equal to R. So half into R, which will be half into 28 root 2 into 28 root 2, right? And I have got two such triangles, right? So if I write area of two triangles is equal to twice of this, half into 28 root 2 into 28 root 2, okay? So this is equal to 28 into 28 into 2, okay? And what is 28 into 28 into 2? You need to calculate this. So I can calculate it like this. This is 8651, 1568 meter square, okay? Now, so area of the required figure is just the sum of this area and this area, right? Which is equal to 2464 plus 1568. Now, if you add 1568 in it, this is 4032 meter square, right? This is one of the methods to calculate this area of this combination of figures. Other way was that you calculate the area of this square, which is 56 squared, right? And then add the areas of these two segments in it, right? In any way, you will arrive at the same answer, which is equal to 4032 meter square. So this is what we are going to do in this chapter. Let's look at the next figure. We need to find the area of shaded region in which ABCD is a square of side 14 centimeter. So this is 14 centimeter, right? So if this length is 14 centimeter, this will be the sum of these diameters, right? So this entire length is 14. So this length is 7. And what is the radius of one circle? It is 7 by 2, right? And we need to find area of shaded region. Area of shaded region is equal to area of square ABCD minus area of 4 circles, right? If I subtract areas of these 4 circles from the area of this square, I will get the area of shaded region, right? Now the question has become pretty simple. What is the area of square ABCD? It is 14 squared, right, minus area of 4 circles. So I will multiply 4 with area of one circle. What is area of one circle? Pi r square. What is r? R is 7 by 2. Right. So this calculation will give me my answer for the area of this shaded region, okay, and the answer will be in centimeter square. So let's try and calculate it. 14 square minus 4 into pi can be written as 22 by 7. 7 square is 7 into 7. 2 square is 2 into 2. So this cancelled by this. 7 got cancelled by this. So this is 14 square minus 22 into 7, okay. 22 into 7 can be written as 154 and 14 square can be written as 196, right. So 196 minus 154 will give me 2 here, 4 here. So 42 centimeter square is the area of the shaded region in this figure, right. So, what we have done in this question is we calculated the area of this square, we calculated the area of these 4 circles, okay. Calculate the area of one circle and multiply it by 4, right. And now I have subtracted the areas of these circles from the area of this square, okay. Find the area of the shaded design where ABCD is square of side 10 centimeter and semicircles are drawn with each side of the square as diameter. So, this is a semicircle, okay. This is a semicircle and I need to calculate these areas, right. So, what I can do is I can calculate the area of this square. What is the area of square ABCD? It is equal to 10 squared, which is equal to 100 centimeter square, right. And what is the radius of this semicircle? It is equal to 5 centimeter. Right. So, area of semicircle is equal to pi r square, which is 5 square by 2, right. So, it is equal to 22 by 7 into 25 by 2, which is 11. So, this will give me 275 by 7 and the unit is centimeter square, right. Now, look at this figure again. If you look at this part only, this part is nothing but the quadrant of a circle, right. Now, if I divide it like this is the segment, this is one segment, right. And I need 8 such segments, 1, 2, 3, 4, 5, 6, 7, 8. So, if I calculate the area of one segment, I just need to multiply it with 8 to get the entire area, right. And what is this angle? This angle is 90 degrees. This radius is 5 centimeter, right. So, area of one segment is equal to area of sector minus area of triangle. Let us name this triangle. If this is O and this is M, we need to calculate area of triangle BMO, right. So, what is area of one sector? It is equal to 90 by 360 pi r square, which is 5 square, minus area of this triangle is half into 5 into 5, right. So, this is the area of one segment. I need to multiply it by 8. So, this will give me 4, okay. So, this is pi by 4 minus 1 by 2. I have taken 25 common, okay. So, this will give me 25 into 22 by 7, 7 into 4 is 28 minus 1 by 2, okay. So, this is 25, 22 minus 14 by 28, okay. And this is 8 by 28, so 25 into 8 by 28, 50 by 7. This is area of one segment, right, this segment. So, if I multiply it by 8, I will get the area of required region. So, area of shaded region is equal to 8 into 50 by 7, which is equal to 400 by 7, and the unit is centimeter square, okay. There can be another method to calculate this area, but I leave it to you to find other method, right? So there can be various methods in mathematics to solve a particular question, but the answer that you will arrive at will be always be the same. Okay, in this question we have got we have got a square and these designs, right? We need to find area of shaded design in the square ABCD of side 10 centimeter. So square ABCD is of side 10 centimeter. Area of square ABCD is equal to 10 square, which is equal to 100 centimeter square, right? And we need to calculate areas of these design. Okay. So what is the plan of action, or what is the plan of solving this question? What we will do is we will subtract these 4 areas 1, 2, 3, 4 from the area of this square. And how do we do that? If you look at this figure carefully, this is a square, right? This is one semicircle, this is another semicircle, right? If I subtract areas of these two semicircles from this square, I will get these two areas 1 and 3. This is 1, this is 3, right? So area of square minus area of two semicircles will give me these two areas. Okay. Now these areas 4 and 2 are also same. Why? Because this figure is symmetric, right? How do you obtain area 2 plus area 4? By subtracting two semicircles from the square, and this was exactly the same way we got area 1 plus 3. So if I can say area 1 plus area 3 is equal to area 2 plus area 4, right? So I just need to calculate this area, and then I will double it to calculate area 1 plus 2 plus 3 plus 4. Once I get this, I will subtract it from the square and I will get the area of the design, right? I hope you have understood that this is a square, these two are semicircles. If I subtract these two semicircles area from the area of this square, I will get these two areas. Okay. In the same manner, these two are another semicircles. If I subtract these, I will get this area. Okay. Once I have got these 4 areas, that is this, I will subtract this from the square to get the area of design. So area of square is 100 centimeter square, okay, and area of one semicircle is equal to half pi r square. What is r? Radius is just this is the diameter, BC is the diameter, and BC is equal to 10. So radius is equal to 5 centimeter. So it is equal to 5 square. This is area of one semicircle, which is equal to 25 pi by 2. So area 1 plus 3 is equal to 100 minus area of these two semicircles. So twice of 25 pi by 2. So this gets cancelled. 100 minus 25 pi. Now if I take pi as 3.14, 100 minus 25 into 3.14. Okay. So you need to multiply 25 by 3.14. So what you can do is you can write it as 100 by 4 into 3.14. So this will be 314 by 4, which is 4 7s are 28, 3 34, so 4 8s are 32, 2 is left, so 4 5s are 20. This is 78.5. So 100 minus 78.5. So it is equal to 21.5 centimeter square, right? So this is equal to second plus fourth area. So area 1 plus 2 plus 3 plus 4 is equal to double of 21.5, that is 43 centimeter square. Now that you have got these 4 areas, this and this, you just need to subtract this from the area of the square to get the area of design. So, area of the design is equal to 100, which is the area of square, minus 43. So, it is equal to 57 centimeter square, right. So, this is the required area, or this is the shaded area, or you can say this is the area of design. How did we get this? We just subtracted 2 semicircles from this square to get these 2 areas, and then these 2 are also same as 1 plus 3, right. Then we just doubled it and subtracted this from the square to get the area of shaded region. Okay. Let us move to the next one.